All right, so we're going to go over problem 91. Here we have this scenario where we got this plane that's flying at an altitude of 5 miles above the ground, and it's going to go over a point directly above this person. It's a tall person. And so we want to essentially, make sense of this diagram first. We have our angle theta there. X is going to be the length of the horizontal distance from the person to the basically to the distance directly under the plane, and the plane is moving in this direction. So, towards the person. So if we thought of this as an x, y coordinate system, it's moving in the negative direction. So we're going to first write theta as a function of x, and then we're going to figure out what d theta dt is when x is 10 miles and when x is 3 miles. All right, so let's see now. This is an angle theta, and with the right triangle, going back to our trig days, we can say that the tangent of theta is equal to the opposite leg or the adjacent leg. So let's start with that. The tangent of theta, so-called TOA, so TOA, opposite leg, which is going to be this side of the triangle, which is 5, over the adjacent, or the base, which is going to be the variable x, so 5 over x. But we need to get theta by itself. So what we're going to do is take the inverse tangent of each side of the equation, because taking the inverse tangent of the tangent is going to undo the operation. So you'll just be left with theta. So what you'll have here then is that theta is equal to the inverse tangent of 5 over x. So now we have an equation for theta as a function of x. Now we got to find d theta dt. So we want to find the change in the angle with respect to time. So d theta dt. And this is going to involve chain rule, because we're going to, d theta dt will be d theta dx, will be the derivative with respect to x, but times dx dt. So let's first find d theta dx by basically using the derivative of the inverse tangent. And if you don't have it memorized, not a problem. I'll write it down right now. So the derivative of the inverse tangent of u, so let's look at how we can use chain rule. The inverse tangent of, whoa. What is going on with this pencil? I usually write clearer than this, I swear. So inverse tangent of u, that'll be equal to the derivative of the inside, so u prime, all over 1 plus u squared. So in this case, we can think of u as 5 over x. So using u substitution, y is 5 over x, or u is 5 over x, which is the same as 5x to the negative 1. And then so u prime will then be negative 5x to negative 2. So with that, we can then find d theta dx. So that'll be then u prime, or negative 5x to the negative 2, all over 1 plus a u squared. U is 5 over x. So 5 over x squared will be 25 over x squared. Let's carry this over to the next line. Now dx dt is just gonna be the change in position or the speed of the plane, and it's moving to the left. Speed is always positive technically, right? Because it doesn't account for distance, it doesn't account for direction. But velocity is positive. Velocity accounts for direction, so velocity can be positive or negative. But it's given to us that the speed of the plane is 400 miles per hour. So then we don't have to worry about like actually finding like a derivative or like having to do any crazy calculations, because we just have to multiply this by 400, and then that'll give us our answer. So let's go ahead. Let's work this out now. Let's put it all together. So d theta dt will be -5 over x squared all over 1 plus 25 over x squared. And this whole thing times -400. So then now we just have to answer those two situations, when x is 10 and when x is 3. So when x is 10, d theta dt will just be -5 over 10 squared, or -5 over 100, over 1 plus 25 over 10 squared, 25 over 10 squared, 25 over 100. So it's a fourth. So 1 plus a fourth to the bottom is just 1.25. And all this times -400. We can go ahead and use our calculator for this. We get a nice whole number, 16. It'll be 16. And since we're talking about we're looking for the change in an angle theta, and we're always going to assume radians if it doesn't specify. So we're going to say 16 radians per hour. Now we just finished a problem for x equals 3 for the second part. X equals 3, d theta dt will be -5 over 9 all over 1 plus 25 over 9 is 1 over 25 over 3 squared. This whole thing times -400. You're probably gonna get some, I can already feel that we're gonna get some like long decimal. This is not gonna become super, it won't be like a really clean number. But in either case, let's see what we get. So 5 times 400. We're gonna get this on top. And 1 plus 25 over 9. 25 divided by 9 plus 1. With that on the bottom. So hopefully I didn't make a mistake. 2, 2, 2, 1, 2. Just go crazy with the 2's. Divided by 3.77777. And we get about 58.8235, which is just about right. 58.82352941. And again, radians per hour. All right, so there you go. I hope that helps. Good luck.